binary operation on x. Take x1 and x2 and combines them in some way to produce an x3 in that. So let's look at some. So first, you have to tell me the set. It is not acceptable to say addition is a binary operation. Addition on what? You have to tell me the set. I don't know any examples of binary operations just based on what we said. So addition on the set of real numbers. So addition on the set of real numbers. If you have a real number plus another, which could be the exact same real number, it could be 0 plus 0 or 2 plus 2, or they could be different. It could be 1 plus pi or whatever. So that produce another real number. What else?
Addition on the integers.
Addition on the integers. Yeah. If you add two integers together, you get another integer. Addition is a really popular one because it's kind of obvious that you take two things and you make a third thing, and they're good examples to have. That addition on the real numbers and addition on the integers, binary operations. Subtraction is also a binary operation on R and on Z. You're ready for it. Are you ready for it? Let P be the set containing the values, the logical values, true and false. Do we have any binary operations on the values true and false? What do we have? We have OR. OR is a binary operation on P. What else? AND is a binary operation on P. Not is not a binary operation because it doesn't take two things. Not would be called a unary operation, which is also just a function from a set to itself. NOR, XOR. These are the two we've seen kind of in depth here. Yes, lies would be one as well. One that people usually don't think of is the natural numbers. You can take the maximum of two elements, take the maximum of the two numbers. You could also do this for the reals, but I'm just throwing out some examples. There's another one called GCD, for greatest common divisor. So the GCD is something we haven't talked about yet. It's not going to be on the exam, but if you've seen this before, it might be helpful to think about, okay, I have two natural numbers. I return their divisor, and that gives me another natural number. Eventually, it could be one of the two natural numbers I started with, but it's two natural numbers and pops them into another natural number. So here are some examples. Now, the tricky part is you need to be sure that you get back something in the set that you initially pulled the two things. So would subtraction on the natural numbers work as an example? Why not? Yeah, 2 is in N, 3 is in N, but 2 minus 3 is not in N. So this is not a binary operation because it doesn't always return something from the same space at the end. So if you remember our definition of Cartesian product, another way that you could define a binary operation is you could say let x be a set. A binary operation on x is a function from the Cartesian product of x with itself, x cross x, to x. Because what is this x cross x, and what do those things look like? These are ordered pairs of elements. So this would mean that you take a pair, x1, x2, and then it gets sent to some other element, which could be the same as one of these. I say some other, but it doesn't have to be distinct from them. So in the case of adding, you would kind of be thinking about, all right, I have a function add, which goes from an ordered pair of natural numbers to the natural numbers, and I could say k1, k2 is mapped to k1 plus k2. Because I want to start thinking about functions as their own things with their own names. So instead of thinking about, oh, addition is this thing I've known since grade school, I want to think about how would I actually define this as a function. And now it has a different name, and that's not a big deal. But thinking about this as a function that takes two things and spits out something else is helpful as you get more into math. Does that make sense? Okay, so you want to try for divides from R cross R to R, take a pair AB, and you would send it to, is this going to work as a binary operation? So the real numbers are okay with 5 divided by 2. The integers would not be. 5 divided by 2 is not integer. So it definitely doesn't work. That's a really good, I'm glad you said that because we need to keep reminding ourselves the difference between Z and R. But 2, 5 would get mapped to 2/5, and that doesn't work because 2/5 is not an integer. Dividing by 0 is the big problem. If you try to do 3, 0, you go to 3 divided by 0, doesn't work.